So here's Justin. Students have seen him before on another instructional video about how to use the electrical power supply. So now I'm going to turn it over to Justin.
Here we see, sorry, I probably shouldn't have stood up there.
It's all right.
Here we have everything that we'll need to set the balance up, the balance itself, the power cord for the balance, a straight drive screwdriver, and a number 1 Phillips drive screwdriver. To begin, we'll find a place to set the balance up. You want to set it up fairly far from anything ferromagnetic. Here we have a wooden table. There are some metal bits of hardware on drawers over here, on the PC to your left, but we generally find that putting the balance right about here is far enough away from all of that. It doesn't cause much of a problem. From there, we'll start by leveling the balance. And Dr. Takash, if I could trouble you to bring the camera over, get a shot right here on top. We have a spirit level. You've probably seen one of these before. When that bubble is in the center of the circle next to it, the balance is level. In order to get it in there, we're going to rotate 2 feet at the back of the balance here. 1 foot here, the other foot there. You can just grab the foot and spin it around. If you spin it in one direction, that side of the balance moves down. Spin it the other way, that side of the balance moves up. If you'll bring the camera back over, take a look at the level here. We see that the bubble is floating this way, meaning that this corner of the balance is too high. So to bring that corner down, we'll rotate the foot. You can see the bubble moving further and further into the circle. And now it's moving roughly along this line between this foot and the fixed foot in front. But you can see we need to move along the opposite line from the other foot to get it a bit closer to the center. We'll move that foot too. And after a little bit of playing around, we've got it pretty nicely centered. Try to look at the spirit level from directly above. That way parallax won't offset the 2 bubbles. So you can see you're looking right from above now, and they're concentric, but if you'll look from a much steeper angle, it'll look like they're off. Well, now that we have it leveled, we will take the top cover off. There are a few things we need to remove that hold the mechanism in place during transport, keep it from getting damaged by jostling around too much, and a few parts inside. So we take our number 1 Phillips driver, and on the back of the balance, we have 2 screws right at the top. If you're watching this video at TU, these will be number 1 Phillips screws. If you have the same model of balance elsewhere, the manufacturer installs Posi-Drive screws. But Posi-Drive screwdrivers are not the easiest thing to find, so we have replaced ours with ordinary Phillips.
I didn't even know they were different.
Usually a Phillips driver will work with a Posi-Drive screw, but they're much easier to strip out that way. So now, this top white piece of metal is free, so we'll gently pry up on it a bit, then use our slot drive screwdriver to pry a bit more from each edge until we're able to easily lift it off and place it to the side. Inside the balance, you'll find sample tubes in a cardboard package. Place those off to the side, and a desiccant. Place that to the side as well. Now we see the mechanism of the balance. These magnets ride up and down, but they are held in place by a clamp here. Otherwise, as they get jostled around, this wire will get stretched out and will have to be replaced.
Which you, in fact, did once.
Yes.
Instead of having to buy an entire new balance.
It's possible to do, but it's not a fun procedure.
Yes.
So
I didn't even want to think of what was involved. I was glad that you were able to save the department several hundred if not $1,000, by fixing this balance instead of having me send it to the manufacturer, have them fix it and send it back at probably $100 an hour.
Well, our shop is always happy to be of help. So to remove the clamp, start by loosening the set screw. Not all the way out, just a few turns. Once that's loosened, you can take the clamp retaining screw at the top off. You may have to hold the clamp a bit so it doesn't torque the mechanism around much. That lifts straight up out, and then the clamp lifts straight out this way. And we'll screw that back on there for safekeeping. Now, on the inside of the cover here, you'll find the sample tube. That just comes out of a plastic clip, and we drop it down right where the clamp was. Now there are 2 magnets underneath this hole. It's not the end of the world if you bump into one, just try not to bump them too hard, and let the tube down smoothly through them. Once it's in place, tighten the set screw back up. Now the balance is almost ready to use, but we're not going to put the cover back on quite yet.
Here you can see the balance, the 2 magnets that the sample tube goes between. And as Justin said, try not to touch those magnets if possible. If you bump them a little bit, it should be okay. But the best is to not touch them at all as you put the sample tube through.
All right. Next, take the power cord. There are 3 connectors on the back here. A red banana jack, a black banana jack, and then all the way on the left, a connector that the power cord, which looks like a headphone cable, just plugs right into. Once that's in place, you can turn it on with the knob on the front. We will select 1X, which makes the instrument more sensitive. And we now have a reading on the screen. We want to get this reading to 0. So we'll use the 0 knob. It's not too important to get it precise at the moment. We're going to 0 it again later. Right now, we just want to make sure we can get close to 0 without having to make an adjustment in the mechanism over here. And you can see we've managed to do that. However, when you first get this out of storage, chances are you will have to adjust it a bit. So, the 0 knob here makes a fine adjustment to the 0, but you can also use this roller, which screws on and off to move back and forth to make a more coarse adjustment. So if you find that you run out of range on the knob here, it can only go so far before it just stops, and you still haven't been able to 0 it, first, get this knob to the middle. Once you've made your coarse adjustments, you're going to need to make some fine-tuning of that. And you can best do that if you have fully half the range of the knob one way, half the range of the knob the other way, so that you can adjust in whatever direction you need to. Now the knob can make 10 full turns, and right now we have it fully counterclockwise. So I'll turn it 5 times clockwise. 1, 2, 3, 4, and 5. Doesn't have to be precise, but now I know I've got about a full 5 turns one way and a full 5 turns the other way. So now, if I spin this roller a few times, you can see that our number has really changed. So we'll try to get this number close to 0. If you can get it within 50 units or so, that's a good adjustment. So I'll give that some rotation. See, after I let go, it takes a little while for it to stabilize. I'm moving it this way, and the number is coming down.
He means toward him when he says this way.
Sorry, was that out of frame?
No. It's getting smaller.
Now it looks like we've gone a bit too far. Give a little nudge back there. Nudge. Alright, so we're off by about 50, 60 units. This is a pretty good place to be. Even once we put it all back together and have a few other influences, we'll have plenty of range to zero it out with the zero knob here. So from here, we'll reinstall the top cover. That will shield the mechanism from wind and stray electric fields. It's not absolutely necessary to put the screws back in now, but they are rather easy to lose. And right back where they came from is always a great place to keep screws. So you can see the reading on the screen has changed noticeably now that we have all this ferromagnetic material. From here, we'll take our screwdrivers, put them far enough away, and the clamp here too, far enough away that nothing is affected. And now, we'll let the balance run for about 10 minutes so that it can stabilize, and then you'll be ready to take data.
Okay. Thank you. So this was video 1. Video 2, the introduction was video 1. So I'm going to stop it now.